Hi, welcome to online tutorial videos from JCBRolabs. For more information, you can visit us at www.jcbrolabs.org. So, in our last video, we talked about the system stability and how can we find whether our system is stable or unstable from the transfer function based on its pole zero plot. And we also learned if we have a higher order transfer function or characteristic equation of higher order, then how to find whether our system is stable or not and how many roots are lying to which side of the S-plane. So this video is a continuation part of it. So in this particular video we will discuss some special cases of routh-hurwitz criteria which we discussed in our last video. So first special case comes when there is a 0 in the first column. So let's go to our theory part. So from our last discussion which we came to know, if there are roots, if there is no sign change in the first column of route table, then our system is stable, and if there are the sign changes or there is negative sign in the first column, then our system is unstable, and number of roots lying towards the right side of the S-plane are equal to the number of times sign is changing from positive to negative and negative to positive. So in the sequence there may be cases there may be some cases when one element of the first column becomes 0. So in that case how to move forward and how to find whether our system is stable or unstable. So this is about routh-hurwitz criteria, special case 1. When one element is 0. So this will be better if we take an example. So let's take, we have a transfer function of some order, say ts is equals to 10 divided by s to the power 5 plus 2s to the power 4 plus 3s cube plus 6s square plus 5s plus 3. So as we learned in from our previous discussion, so first step will be we will start from s to the power 5, then we'll go for s to the power 4, then s cube, then s square, and we will move all up to 0. Then we will have s to the power 1 and then s to the power 0. So then now we will write the coefficient of odd powers, because first power is the odd power. So we will start from odd powers of s. So first the coefficient of s to the power 5, then the coefficient of s to the power 3, then the coefficient of s to the power 1. So it's 5. Now the second column or the second row of this route table, s to the power 4, so coefficient of s to the power 4 2, then coefficient of s square, then coefficient of s to the power 0, that is 3. So in order to calculate this first element, as we know, so we will create a matrix of these, we will try to find the negative determinant of these two. So this will be this multiplied by this minus this multiplied by this divided by this element. So this will be 1 into 3, okay, 2 into 3 minus 1 into 6 divided by 2, okay, and it becomes 0. So now what to do that? Okay, now let's create a second table. So in second table we will multiply this element with, that means let's have a different color, this element multiply with this, and this element multiply with this divided by this. That means it will become 2 into 5 minus 1 into 3 divided by 2, and it will become 10 minus 3 is 7 by 2. So now the problem is, now if we start writing this the coefficient for s square, right, the problem will be like we multiply with this 0 into 6 minus 2 into 7 by 2 divided by 0. So whole element will become the infinity term. So the trick is, instead of this writing 0, we assume that it is a very small number, epsilon. That means epsilon is a very small number and it tends to 0. Okay, so we can assume whether it is a negative number or positive. So generally we assume it's a positive number, and then we calculate towards the negative side, like how many times, whether our sign, because we are only interested in sign, so then we will be based on the calculation we will learn whether sign is changing or no. So while calculating the term this s square, it will be epsilon multiplied by 6 minus 2 into 7 by 2, that will be 7 divided by epsilon. Now for this second row, this will be this term multiplied by 3 minus 2 into 0, because this element is 0, third element, divided by epsilon. So this term will be 3 only, right? Similarly, now we will move forward. Now what we'll have, now for calculating the coefficient of s to the power 1, we have this table, right? So in this table, this particular term multiplied by this 7 by 2 minus epsilon multiplied with this 3. Okay, so this is a little trick, little complicated, so let's direct write it out. So it will become 42 times a minus 49 minus 6a square. So you can say this is small number anything, so I am saying it as a, and it is a small number which tends to 0, divided by 12a minus 14. Okay, and now for calculating the second number, this term multiply with this 0, our next term is also 0 in this case, and epsilon multiply by 0, so everything will be 0, so next term will be 0. Now for calculating this s to the power 0, this term multiply with this 3 minus this term multiply by 0 divided by this term, so obviously it will become only 3, because this will cancel out. So if you have a confusion, you can solve it on your own. So now our route table is clear, so let's make it a little clean by removing this. Okay, we have removed some extra component. This was E. Okay, now we are only interested in the first column, and that to the signs of the first column. Now let's put some signs here. So the sign of the element is here plus, and here the term was epsilon, right? So the sign we have assumed is a positive small number, let's say it's plus. Now think about this, and let's have a little rough work here. So it is 6a minus 7 divided by a. So we have assumed this a is not the 0, it's a very small number. So if this a is a small positive number, then this complete 6a number will be very small, right? Because suppose a is 0.071, So this 6 times e will be 0.06, and you are subtracting it from 7. So overall upper side sign will be negative, and this is also a positive number, so negative by positive, so ultimately the sign will be negative only. So we'll have a negative sign here. Now we have another term like this one, 42a. So let's have 42a minus 49 minus 6a square divided by 12a minus 14. So in this case, again this is small and this will be very small, and all these terms are being subtracted from minus 45. So overall sign on the numerator will be negative sign. So total numerator sign will be negative, and in denominator this 12a, again this will become a small, and then we are subtracting from minus 14, so sign will be again minus. So let me repeat it. This e is very small number, so 42a will be again small, and this will be very small, so overall sign will be negative. Similarly here 12a is also a small number, and we are subtracting from minus 14, so 14 will be larger, so overall sign will be negative, and this negative and negative becomes a positive number. So this will be a positive, and then this will be a positive. So now our thing is done. So now we have a negative sign here, so it indicates like our system is unstable. So system described by this TS is unstable. So we can conclude system is unstable. And one more thing, and we have how many roots? This first time sign is changing from this positive to negative, and the second time sign is changing from this negative to positive. So overall 2 times sign is changing. So system is unstable, and we have 2 roots on right side of S-plane. So my writing seems to be a little vague. So 2 roots on right side of S-plane. So this is how we deal when we encounter a 0 in one element within the first column. So because this 0 is important, because we have to divide it by 0, so number tends to infinity, so we want to avoid that. So this is how we deal with this special case 1 when we have one element 0 in the first column. And now in our next video we'll talk about when entire row becomes 0. Okay, so this could be because it's mathematics, and mathematics this 0 can occur. So what happens if this element becomes 0, the second element also becomes 0, and the third element is also 0. So how to move forward in that case, and how what are the several conclusions which can be point out from that case when all the complete row becomes 0. So we will discuss about that in our next video. So that's it for this video. Thank you.